welcome back. So I'm Johnny and you're watching Odds and Ends Machining. So if you haven't already guessed it, today's video is going to be about my mini bike. Now I've made a few of these mini bikes. I race them on the back track at Manfield, something called bucket racing here in New Zealand. The only rules are on engine displacement, being 100cc water-cooled two-stroke, 125cc air-cooled two-stroke with a carburetor size limit, and 150cc four-stroke. So my bike is 140 plus cc's. It's just a Lifan motor, and I make my own frames and use a few off-the-shelf parts. So you can check how I made one of those frames out in a previous video, and there's also some onboard footage of me racing a previous version of the engine on the channel as well. So I raced my mini bike at Manfield. I've gone ahead and made a new frame. I've given it the wheelbase I want and the rake. Now, other than that though, the bike has had some handling woos in the past. It's amazing in low speed corners, it handles really well, but in the high speed stuff, the bike just wallows across the track and it's quite uncomfortable and it slows you down a little bit as you can't lean right over and you get some chatter issues. So what we're doing today is addressing those chatter issues. Now, how we're going to do that? We are going to design a new fork lower. So I've already gone ahead and done this, but we're going to go through how I did this after this. But essentially what we've done is we've taken the axle mounting point of the standard fork, which is about 12 to 15 millimeters further forward, and we've moved it central. So what this does is increase the trail. So your steering geometry is mostly made up of your rake and your trail. Now the trail is an imaginary line, and the more trail you have, the more stable the bike is. So what we're doing here is shifting the axle rearward in an effort to increase the trail and add stability to the bike. We've also added this radial caliper adapter so we can swap to a 4-piston caliper from the standard 2-piston we've been using, and we've also given it provision for a larger disc, 30 millimeters larger in diameter, because the standard disc was going blue and overheating with the amount of braking we were doing. So in today's video we'll look at this and this. You can even see how this adapter was made in a previous video. I've made one before for a mate of mine and his bike. And before we carry on, I'd like to say a massive thanks to today's video sponsor, JLC CNC. Not only for sponsoring the video, but providing these amazing parts, which will allow me to get back to racing my mini bike sooner. Making parts with JLC CNC is as easy as getting your CAD file in a supported format, uploading it to their website and selecting your parameters from your tolerance, your surface finish, any threads, and you can even choose bead blasting and anodizing, as I've done here in this case, in these two colors.
Check out the options on their website, but there is a whole host of other options for anodizing colors and surface finishes.
And then from there, choose your shipping method and check out. And in my case, I had these parts within about a week. So a massive thanks to JLC CNC. So here are the finished parts. Now I'll talk a little bit about them and explain some of the changes that were made. So the first change, we have a brake adapter to hold our cheap Chinese caliper. It screws on and locates perfectly on the bosses. So that should give us a massive upgrade in stopping power. Some of the other changes that were made is this face here for mounting a front fender. On the standard fork, it is curved and it is horrible to mount things to. So now I can just mount a small piece of equal angle aluminium, a little bracket, and bolt on the fender. You'll notice the threads are the same, the depth is the same, and JLC hit all of the tolerances perfectly. The other main difference you're going to notice is a pinch bolt. So the reason that's important is because when you have your two forks, they need to be perfectly parallel as they slide in and out. Now, if you miscalculate the size of your spacers for your wheel, or pinched, and as they go in, they start binding. So with a pinch bolt, the axle actually floats as you tighten the front wheel up. And then once everything's been bounced up and down the forks, you can pinch these up, and then the forks will be in perfect alignment, giving far more controlled movement. So it's a superior design, probably not done here because it involves a slitting operation, drilling and tapping 2 extra holes. So this is just cheap. So this is a premium feature. We've also moved the axle rearward central. So I've done a sketch on the computer and worked out the rake, or worked out the trail numbers for this fork setup versus this fork setup. And with this setup, we're looking at a trail of around, it was somewhere between 40 and 50 mils off the top of my head. So not a lot of trail. When you think about a 125 Grand Prix bike, you're looking at around about 87, 88 millimeters of trail. So what this has done is this has increased the trail to, I believe, about 60 plus millimeters. And this is the first step in getting the bike to handle. Our next step is to change the offset on the triple clamps, and that will make the trail increase even more and give the bike even more stability. So I thought I'd do this first, make a small change, increase the trail, see how the bike behaves, and then if I wanted to increase it more, I will make new triple clamps that shift the forks further rearward with less offset. But as you can see, the parts look amazing, and now we will assemble them onto the fork. So you'll have to excuse all of the mess. There's a bit of development happening for the V-twin production motor, but we'll worry about that in another video. So here's our fork. The lower is threaded, M33 by 1.25, and it is secured with a lot of retaining compound. That's why it requires a lot of heat to remove the lower. But the threads work perfectly. Slide in, and then I should be able to just twist this the whole way up. At the moment, I'm not going to be using retaining compound as they're going to go together and come apart a few times, but there you go, all the way up, and there's our new fork lower.
So now we're going to spend some time on Fusion 360. So what I've already done is I've done some sketches on a piece of paper. They'll show up on screen, but what you essentially need to do is get all of your dimensions. You can do this as you go, which is what I usually do, but for this case I've pre-jotted them on a piece of paper so I can show you how to draw this part. So the first thing we're going to do is draw a cylinder. Now we're going to look at the top plane, draw a center diameter circle. I'll turn 3D sketch off because I was using it earlier. We'll put a circle there and we'll dimension it at 43 millimeters. 43. What we're going to do is extrude the circle, and we're going to extrude it 112 millimeters. Boom. This here is our or going to be, our fork leg. The next thing we're going to do is hollow it out. So what I know is that it is 43 millimeters in diameter, and the ID is 33 millimeters. So we'll go 33, and it goes down 25 millimeters, and then it goes down to 52 millimeters. So what we're going to do is, scratch that, let's go down to 52 millimeters the whole way down, and then we know it's threaded. Now it's actually not threaded the whole way down, and it's threaded in M33 by 1.25, which is not an option here, but that doesn't matter, as you can annotate it on a drawing when outsourcing these parts, and they will just do the threads you've annotated on the drawing. So we're going to get rid of full length, we're going to do an offset, and we're going to go 25 millimeters, and then our threads are going to be also 25 millimeters, and then we have it, our threads, and then the bottom of our hole. The next thing that we're going to do is place the axle on the cylinder. So now we're going to sketch on the front plane. We're going to use our project. So if we go into our create tab, to project and include project, and we just click the cylinder. Now what this does on our sketches is sketch 3, we now have a reference of the cylinder, so we can draw a line. So we can draw a line, and I'm just going to do a construction line from the midpoint to the midpoint, and then I'm going to draw a circle, which will just be a normal circle. It'll be 15 mils in diameter. Boom. And I know that that circle is 85 millimeters from the top of the part. So we can go circle, top of the part, 85 millimeters. There we go. Now what we're also going to do is draw another circle outside of that. We can either draw a circle like so, or go to offset, and let's go 7 millimeters. We'll go finish sketch. Now we're gonna extrude this sketch, and we're gonna go symmetric, whole length, and we're gonna go 43 millimeters, and we're gonna go join, and this is gonna give us our, let's go 44 millimeters, and that's where our axle is gonna go through. So we turn that sketch back on, do another extrude, we'll just do the center section, we'll do the exact same thing, symmetric, whole, distance, all, and there we go, we have our 15mm hole through the entire part. Pretty cool. Now what we can do while we're here on this plane, so we can draw another sketch, and we can actually sculpt this and give it some shape. So what we'll do is we'll project it again. So what projecting does is it allows us to reference these other pieces in our new sketch. So if I draw a line, see how it's not snapping to any of the geometry? It's because it doesn't exist. So if you draw something in sketch 1, it's not going to be in sketch 4. You can't reference it without projecting. So you have to go there, manually project. You can either project the whole thing, or just this line, maybe this circle, you go OK. And now when I go to line, to draw my line, I can actually click on these points and it will snap to them. So what we'll do is we'll come down here, 75 mil, 75, for no reason other than it sounds good. We'll draw another line here, and we'll just draw it like that. See how it's tangent, but it's on an angle and it's blue. So this means thing's not constrained, I can just move it around. So what we're going to do is we'll make it perpendicular. So there should be a perpendicular constraint here, perpendicular to this. Now it's 90 degrees and tangent, so that's pretty cool. And we can get our arc, a 3-point arc. We can go from this point to here, make it tangent, and now we've got this nice tangent. We can get a fillet, we can come in here, and we can make that any size we want, and we'll just go enter. And now we have some geometry. So something cool we can do here is we can use this feature called mirror. We can click on this object, double click it, the whole line, and we can use the center line here as our mirror line, and it will just create an exact opposite of what we just did. And we can go finish sketch. Now when we turn the bodies back on, this is the solid body, so you can turn them on and off. It's quite helpful when trying to select things. You can see we're going to cut away some of the body. So to do that, we have to actually connect this sketch up here. So we'll go back into our sketch, and we're just going to draw some lines connecting this point to this point. And in a second, you will see when we go to extrude, we can select here and here. We go symmetric, distance, all. Okay. And now we've cut away a bunch of the fork. Pretty cool. So the next thing we're going to do is put a slot in here for a pinch bolt. So the way we're going to do that is we're going to sketch on, doesn't matter where we sketch this line, any of these planes. We're just going to draw a vertical line. And I want to use the center point here to start my sketch. So what I'll do is I'll press P for project, click that point and go enter. And now when I select line, I can click on this point, drag it down to my origin and go tick. And now I'm going to do what's called a thin extrude. So I'll do extrude, come over to the side, select thin extrude and click this line. Now what I'm going to do is go symmetric, distance all, it's just going to do everything, and I want to make this wall thickness, well, let's see, well, it's not going to do it, I have to actually just drag it out, but it's going to leave a 1mm wall there. And we're going to go, see how it's offset, you've got side 1, side 2 and center. I'll just go center, so now we have a nice offset, a nice central cut through the bottom of the fork. So we'll turn our sketches off, and here's our part right now. It looks pretty cool. So we can draw on the front here. This is a new plane. Pretty much any flat surface is a plane. We can't draw on this or this curve, but we can draw on any flat surface. What I'm going to do now is project our little cylinder on the inside, and that's what we're going to get. Now we're going to use our line. We're going to use a construction line. We're going to put a vertical line in the middle. And the reason we're doing this is because we can find the middle of this line. A little triangle appears. We can go out to here. And now we can go create a point, and we can put a point on here. Pretty cool. We can use our mirror, We can mirror this point on this line. Now we've got 2 points. Pretty cool. Now we're going to go hole, and we can click on these 2 points and make some holes. But it's much more complicated than that. We can say we want a counterbore hole with a thread. We want to use a 6mm cap head. We've got 6mm. We know we want the top to be 11mm, and we only want it to be half as deep. And then we actually don't want it threaded the whole way through, but for this we'll just thread it the entire way through. And there you go. Or we can go back into it and we can change that to offset. Let's see if we can do it. It should be not quite. That's okay. So what we can also do, I want to do this properly now, is we can go hole here and here. Read all of that, so yep, but we'll get rid of the threads, keep it simple, and we'll go 11 by 0.5, and we'll make this hole 6 mils, and we're only going to go to 2. We can click on this face, a flat bottom, and there you go. There is a clearance hole to there. Now we can turn that sketch back on, and let's try do 2 more holes, tapped, all 6mm, blah blah blah, and it should put the thread on the second half. Turn the sketch off, and there we go. We've got a thread in there and a clearance here for our nice little pinch bolts. And now the last steps, let's add on the caliper mounts. So we're going to sketch on this center section again. We're going to project this as I need the location, as I've triangulated the mounts. And we're going to draw 2 lines. We're going to make it a construction line, because we're not actually extruding from this geometry. It's just to put some holes in the right spot. So we've got 55. We know vertically above that we got 44 mils between the caliper mount bolts. You can see this little icon here means this line will always be vertical. So as you can see, it's free to move because I haven't put a distance from this point to this point, which I will do now. I will draw another line from here to here. And we're going to dimension that line, and we're going to make that 87.5 millimeters. And this is pretty much where the caliper needs to go. Now I've kind of rushed this for you guys, so this isn't as accurate. Don't take these numbers for gospel, you'll have to measure it yourself. But that's why 3D printing these parts in the end is a really good way to test out all of your dimensioning without wasting too much money. And then from there, what we're going to do is use our offset. So we've drawn 2 8mm circles for the M8 bolts. And what we're going to do is we'll just do an offset 6mm. Sounds like a good enough amount of meat. 6mm. Pretty cool. And now we can project this. You do this projecting an awful lot in Fusion. And we are going to move from this point at the top to here. So now that is tangent to the circle, and it's attached at the top point. And we'll do something similar here. We'll go from this point, and we'll go tangent. You move it along enough, and it will go tangent, and automatically apply a constraint. Now we're going to do a 3-point arc. We'll just pick 2 points, just draw a nice little arc, and I don't know what happened there. We'll do that again. We'll draw an arc, a 3-point arc, 2 points. There you go, nice little arc. Now it's not tangent to anything, so what I've done is I've clicked tangent up here, click the arc, and now it's tangent to both of the circles. Now I can finish that up. I can either drag it around or just dimension it and just go 14 millimeters, and there it is. We can also do one other thing while we're here, and we can go offset, and we can actually offset these as well. So if we go 5 mil, let's do this minus 5 mil because we want it to go the other direction, and we'll go 5 mil. And now we can go extrude. And so we're going to have to select all this geometry, so we can just do it like that. We've got all our geometry, we don't actually want the centers there. And we'll go again, symmetric, whole length. And measuring the caliper in front of me now, we're going to go 13.5 pardon me, 13.5 millimeters, so 13.5, and that was symmetric, whole length, good to go. But what you'll notice is just here on these faces, they're not quite touching. So what we can do about that, the easiest way to deal with this, or I would deal with this, is just to do this. Just draw an extra line here, come in 3 mil, and then just come straight down to here. Now, when we extrude the part, just make sure we also, well, look at this, not connected. Just quickly connect these up. I don't know what happened there. Boom. Now when we extrude, select all this and do our deselect, distance, symmetric, whole length 13.5 mil. We're going to go join. There you go, we end up with this. Very cool. Now we'll turn that sketch back on, extrude again, just select these two, and we're going to go symmetric, so no, pardon me, symmetric, distance, whole length, and we're going to go 14, we'll go 15 millimeters. We're going to go join. It's just going to raise the bosses a little bit, like so. Now we're just going to remove some weight. So we're going to sketch on this plane now. We're going to turn this back on, and we're going to project some stuff. So we're going to project this line, this circle, this line, this circle, this line, and this line. Go OK. So just connect that up. Everything's connected up. We should be able to extrude. Just select this and let's go. -3. Enter. And there you go. We've now wasted away some weight. Now what we can do before we do anything else, let's go back to that sketch. I don't like this up here because this is perpendicular to this and not parallel to this, so delete this, parallel, Now that should clean up a little bit. There you go. So this is what we've done. What we can do before we do anything else is go to Create, Correction, go to Construct, go to a mid-plane. We don't actually need to do that. So we can go to Create, Mirror, and we're going to go Features. So you select Mirror. You can mirror anything, you can mirror any of this stuff. So go Features, we're going to select that last extrude we did. We're going to use our mirror plane as this plane, because it is in the middle. And we can just go Adjust, OK. And it's done the same thing on the other side now, without redoing all those steps. And then we can do all these fillets. And we're going to go at least 3.5mm, because then they can machine these with a 3.5mm end mill. So you go 3.5. Very cool. You go plus, and we hit the bottom here, and we're going to use a 1mm bull nose. And there you go. That is a very neat little radius. And we can do that again, just mirror, features, we'll click on that fillet, click on the plane, hit adjust, OK, and it didn't work. So what if we try that again? Click on the plane, and then we're going to click identical. Nah, it's not going to work. Easiest way to do that then is to just do another fillet, select all the points. Sometimes you can even just draw half of the object and mirror the whole object. That's how I do things sometimes. So we'll go 3.5, and then we'll go, oh, pardon me, I don't want that, I want 1. And there we go. There's our fork lower with our threads, our brake mount, and the only thing left to do is put a fender mount on the front of it. And the easiest way to do that is we'll just go offset plane. We'll just offset a plane from here about maybe 15mm. We'll sketch on said plane, project it again, so press P, we'll just draw a line to project that, enter, now we'll draw a line. Why is it not projecting? Odd. There we go. So we're going to draw a line, and then we're going to come down. And it's come down about 40mm. 40. We're going to draw a center point rectangle. And we're going to go, I like that, we're going to go 30 by 17, just because it doesn't matter. Turn off construction, and there we go. We're going to fillet all the corners to make it look pretty. And we're going to make those 3mm fillets, extrude. We're going to select the profile. I'm going to go distance to object, click this, join, OK. And then you guessed it, we're going to sketch on the face. And go L for line, X for construction. And draw a vertical line down, middle across. You guessed it, we're going to do a point. We're going to mirror that point. We go OK, finish sketch, hole. You see where we're going with this. And what we're going to do is chuck in some M5 holes, and they are not going to be counterbored. And there you go. Some M5 holes. And the last thing we'll do is add fillets to most stuff. So for there, we're going to go for, they're going to use a bull nose. So add a 3mm fillet, looks nice. We can also add fillets to these surfaces here. We'll see what we can get away with. It might not like it too much. We'll go 1mm. It'll do it. Let's see, can we do a 2mm? Looks quite nice. Can we do a 3mm? There we go, 3mm fillet. And then we'll make these look pretty because they're kind of ugly. Bang. Bang, bang, bang. Oh yeah, that works. Maybe chuck some 5mm on there. And maybe another couple of 3mm on here. And then what we're going to do, because we're not savages, is we're just going to chamfer all of these edges, because it looks nice. And if they can't machine something, most places, they'll just let you know. And we'll go with a 0.5mm chamfer, and then we'll quickly get the top of the rest of the part chamfered. Oh, it won't let us do it. Well, that's okay. But we definitely want the entrance to this to be chamfered. And we'll put a radius on here because it'll look nice. And there you have it. In a little over 28 minutes, we've drawn the entire fork lower, maybe with some dubious dimensioning, but that is how you do it. I have glanced over a lot of things and haven't explained how to use Fusion 360. I don't think that was my goal here. It was just to show you how easy it is to draw a component, because now I could put this on the 3D printer and have it in my hands in the morning to test fit it to the bike prior to outsourcing the manufacture. So if you want to see more of these Fusion videos, let me know. Otherwise, it was fun trying it as a one-off.